created by MindSticks Foundation Trust.
Welcome to today's Explainer, students. Here is our agenda for today. We will cover the shape of everyday objects, the anatomy of a frustum, formulas for the frustum, solving real-world problems, and finally, sectors of a circle. Let's dive right in.
Section 1. The shape of everyday objects. To begin our geometry lesson today, let's first try to recognize the complex mathematics hiding right inside our very own kitchens. If you observe this simple glass of water, you might automatically think it's just a standard cylinder, right? But let's look a little closer together. The top is actually quite a bit wider than the bottom. Because these sides are gently tapering down, it absolutely isn't a cylinder. Instead, it forms a very specific, fascinating geometric shape known mathematically as the frustum of a cone. And you know, even the water resting inside it takes on that exact same shape. Now, the word frustum might sound like a pretty intimidating term. It kind of sounds like something you would only hear in an advanced university lecture, doesn't it? But honestly, by definition, it's incredibly straightforward. A frustum is simply the shape that remains when you take a standard, everyday cone and you slice the top right off. The only rule is you have to make absolutely sure your cut is perfectly parallel to its circular base. Looking right here, we can beautifully visualize this whole process. By making that parallel horizontal cut straight through our cone, we are separating the original shape into two completely distinct pieces. We get this smaller, brand new cone right at the top, which we just remove and set aside. And what is left sitting securely at the bottom? Well, that is our target shape. That is our frustum. Section 2. Anatomy of a frustum. So now that we can clearly visualize this everyday shape and we know exactly how it's formed, let's carefully break down its anatomical dimensions. Just like a cylinder or a basic cone, a frustum has a few specific measurements we absolutely must identify to work with it. First, we have a straight vertical height, drawn directly from the center of the top base straight down to the center of the bottom base. We will denote this as h. Then we have the slanted outer edge, which we call the slant height, or L. And here is the most important part, the real difference from a regular cylinder. It has two completely different circular faces. The larger radius at the wider end is R1, and the smaller radius down at the narrow end, we'll call that R2.
Section 3. Formulas for the frustum.
To actually measure these shapes in real life, say if you were figuring out how much glass you need to manufacture these drinking cups, or maybe you want to paint a lampshade, we need to add a few crucial mathematical formulas to our toolkit. Notice how the formulas for the slant height, the curved surface area, and the total surface area all carefully incorporate both that larger radius R1 and the smaller radius R2. It makes perfect sense when you think about it. For example, to find the total surface area, it's a very logical step-by-step process. We calculate the curved outer wall first, and then we simply add the areas of our two flat circles, the top and the bottom.
Furthermore, if we want to know exactly how much liquid our glass can hold, we have to use this specific volume formula right here. I highly recommend you jot this equation down in your notebooks. Now, I know it looks a bit lengthy with those fractions and squared radii, but please don't let it overwhelm you. Once you actually plug in your given measurements, it just becomes basic arithmetic.
Section 4. Solving real-world problems. Let's put our newly learned mathematical tools to the test by solving a practical, real-world example straight out of our textbook. Because really, mathematics is only truly useful when we apply it to the world around us, right? Consider this everyday frustum-shaped bucket. Imagine you need to know exactly how much water this bucket will hold so you can wash your clothes. Well, we're given a top radius of 15 centimeters, a bottom radius of 12 centimeters, and a total vertical height of 28 centimeters. So we've got all our variables ready to go. Let's solve this systematically together. Step 1 is always to identify our variables, which we just did. Step 2, we carefully substitute our R1, our R2, and our height right into that volume formula we just wrote down in our notebooks. After calculating the squares, adding them up, and multiplying by 1/3 pi and our height, we arrive at a total volume of 16,104 cubic centimeters. Now, to put that into perspective, since 1,000 cubic centimeters make exactly 1 liter, we simply divide by 1,000. And there we have it. We successfully discovered that the bucket's total capacity is 16.104 liters. Excellent work following along with that calculation, students.
Section 5. Sectors of a circle.
For our final topic today, we are going to step away from 3D volumes for just a moment and shift our focus back to a really fundamental concept in 2D geometry, the circle. Within any circle, we have a very specific area known as a sector. Basically, when a central angle divides a circular region into two parts, each part is defined as a sector. Honestly, it's exactly like slicing a perfectly round pizza. Whenever you take a slice, you're literally taking a sector. Mathematically speaking, the sector is defined precisely as the part enclosed by two radii of the circle and the curved arc that connects their endpoints.
Now, what's really fascinating here is how this visually separates the space. If you look closely, those two radii originating right from the center point O separate the entire circle into two distinct parts. The smaller slice, the one you'd probably eat first, is called the minor sector. And that much larger remaining slice, basically the rest of the entire circle, well, we call that the major sector.
The absolutely crucial distinction to remember for your exams is this very simple comparison. The minor sector is always bounded by the shorter curve, which is known as the minor arc. And conversely, the major sector is bounded by the longer curve, which we logically call the major arc. It's a very straightforward, easy-to-remember naming system, isn't it?
As we wrap up today's explainer, I want to leave you with a little challenge. I urge you to take your eyes off the screen for a moment, look around your own home, and ask yourself, what other complex geometric shapes are hiding in plain sight? Is the lampshade on your desk a frustum? Is that open slice of cake in the fridge a sector? Mathematics is quite literally everywhere once you know exactly what to look for. Thank you so much for your excellent focus today, students, and as always, keep learning.